Alright guys, so I promised to send you an online video about a little review on plate tectonics because we did run a little bit out of time towards the end. Remember that our objectives were to explain the theory of plate tectonics as well as describe the three types of plate boundaries. I believe we got quite a bit done, so if you want, go ahead and get your notes out, pause this video, get your notes out, and let's go ahead and fill in the blanks of what we haven't filled out already. So the first part, we watched a little video about continental drift, which was a little bit different from the video that we saw before. We said that Pangea began to drift apart about 225 million years ago, and it's at a very slow rate of about 1 to 10 centimeters per year. We talked about Dr. Wilson, who was the father of this theory of plate tectonics. He put together a lot of evidence, including the idea of the Great Rift Valley in East Africa. And remember that when we're talking about scientific theories, it's going to be a well-tested concept that explains a wide range of observations. Okay? So it's not just a bunch of conjectures, but it's also the evidence that supports it. When we're talking about specifically the theory of plate tectonics, we're talking about that this movement is kind of driven by these convection currents that are occurring in the mantle, particularly in the asthenosphere. Okay, we talked about the different lithospheric plates and what happens at the boundaries of each of these. Okay, we went through PhET and we did our own simulations. And again, to explain my expectations for what's to be turned in class on Tuesday are the 3 simulations that we kind of already did on Wednesday, as well as 2 new simulations that we did not do. Okay? So 3 simulations that we already covered, as well as 2 simulations that we did not do, as well as any follow-up questions, any diagrams that should be thrown in there. So I believe that brings us to the point where we left off on our PowerPoint. So our next point is going to be plate boundaries. So when we're talking about plate boundaries, we could also mention faults. And these faults, and hopefully your teachers, remember there is Aldo, Lillian, and Victoria, who are excellent teachers. Okay, they went through the Snickers part of the lab for you guys. They told you to take your fingernail and make little breaks in your Snickers bars, right? And these little breaks are going to be faults of those plates, okay? Then we went ahead and with those Snickers bars, we did 3 different types of boundaries. We did a transform boundary, in which 2 plates slip past each other and they're moving in opposite directions. And again, guys, if you need any moment to pause this video so that way you could copy these into your notes, feel free to do so, okay? So in this transform boundary, they're moving in opposite directions. This is where earthquakes tend to occur, okay? Remember, your Snicker bars were really breaking up at that point. And there's some examples, including the San Andreas Fault, which is in California. And remember that when we're talking about those transform boundaries, crust is neither created nor is it destroyed. It's just kind of crumbling up, okay? A lot of seismic activity that's going on. Here's a picture of the San Andreas Faults. It covers quite a bit of the length of California. However, the most active parts you're going to see here in the blue, okay? The most active parts you're going to see right there in the bluish teal color. And here is actually a really cool picture of the San Andreas Fault. You see how much that transform boundary is kind of creating these seismic activities, okay? Divergent boundary, remember that's when they're going in opposite directions for divergent. These 2 plates are moving apart. They usually occur in the mid-ocean ridge or on land. And these boundaries can form rift valleys or deep-sea trenches, okay? So the example that we saw in a video was the Great Rift Valley, which has a 3,000 kilometer crack right down the middle of it. This is also considered to be the cradle of humanity. There is also a rift valley that's pretty close to us, okay? So if we see here on the map, this is going to be the northwestern border of Texas. We see El Paso here, Lubbock and Amarillo is going to be here, okay? We see here New Mexico, Colorado. This Great Rift Valley which is in Africa, is similar to the Rift Valley that we have here in the Southwest, the Rio Grande Rift Valley. When we're talking about plate tectonics, there's something called magma, which you guys have heard before. It's basically melted or molten rock. And this magma that's erupting through the mid-ocean ridge and the Rift Valley, and I believe it was one of the follow-up questions in your PhET lab, what is this new crust that's coming in? It's this magma that as it comes up, it's really, really hot in the mantle, in the asthenosphere. But as it comes into the lithosphere and starts to get towards the surface of the Earth and to become the new crust, it starts to cool down. And so what we're forming is new crust using that magma from the asthenosphere. And finally, convergent boundaries, that's when two plates are going to come together, and it's a collision. And at this collision, there can be mountain range formations. Now there is the question here, why isn't one subducted beneath the other? Well, the reason is because they actually have pretty similar density and how thick they are. When we saw the oceanic crust, we saw that it was very thin crust, but our continental crust was pretty thick. So when you have two thick slabs of plate tectonics going on and they're coming in towards each other, there's not much room for one to go underneath the other. They collide, and what we start to see is this formation of mountains. Okay, for example, the Appalachian Mountains on the East Coast, some of you guys are interested in going to East Coast colleges, is an example of when these two plates collide. The density of the plate determines which plate comes out on top more than the other. So while there's no subduction in which one plate is going into the mantle, one plate could end up higher up than the other. Okay, so that depends on the density. If it's more dense, it's more likely to end up on the bottom, and if it's less dense, it's more likely to end up on top. So here's a picture of the Appalachian Mountains. I have never been, but I would love to go, especially right now since it's fall. This is pretty much the range of the East Coast, with the Appalachian Mountains being in Virginia and Kentucky and Tennessee. All right, this part I believe is one of the parts where you have to write down a few things. Okay, so if you have two oceanic boundaries, remember one is going to go on top, the less dense one, while the more dense one is going to be subducted. When you have oceanic and continental, the oceanic plate tends to be more dense, okay, and it tends to sink. When you have continental and continental, that's when you have those convergent boundaries that form mountains. Okay. The Snickers science portion of the lab. Let's see. For the Snickers science portion of the lab, I believe I'm going to have to post another YouTube video to help you out on the notes for the first paragraph or so, as well as examples of diagrams that I expect from you guys. Okay. So that was in the last 20-15 minutes of class. And that was again run by the 3 teachers that I asked to help you guys. And so perhaps you guys weren't able to do everything, so I will create another video to make sure that you guys get that information. Okay, the last thing that I wanted you guys to do was an exit ticket. And this exit ticket asks you 2 questions. The first question is, what properties affect the buoyancy of plates? And the second question is, what is the difference between the 3 different types of boundaries? Okay, remember those 3 different types: transform, divergent, and convergent. They're not in any particular order. You could remember them however you like. Transform, divergent, and convergent. And I want you to explain the results that happen for each one. Remember that the results can vary based on what types, whether you have oceanic and oceanic, oceanic and continental, or continental and continental that are touching. Okay, so I want you guys to think what happens during each of those boundaries. Okay, go ahead and write that down on your notes as a little thought. Okay, and I'll see you guys on Tuesday. I hope you guys have a great weekend.